This is Chapter 3, which is straight lines and linear functions. Section 3.1, the geometry of lines. A lot of this stuff may be familiar to you if you took a course in high school algebra or also geometry. So, slope. Definition. Let P1 with coordinates x1, y1 and P2 with coordinates x2, y2 be 2 points on a non-vertical line. And the slope of the line, which is denoted by the letter m has always stood for slope, is given by m is equal to y2 minus y1 over x2 minus x1. Notice it's just a calculation. The little subscripts on the variables means that somehow, some way, those points will be made known to you. Now, slope is also called the change in y over the change in x, or rise over run. How far you move up and down, the difference in the y, that's the rise. How far you move left or right, that's the difference in the x's, that's the run. Now, the slope of a vertical line is undefined or does not exist. So only non-vertical lines have a slope. When we do some examples, we'll actually see the algebraic reason why a vertical line, the slope does not exist. So, warning. Number 1, do not say no slope when you mean the slope does not exist. If the slope does not exist, then say slope does not exist. Or if you want to say that the slope is undefined. Number 2, do not say no slope when you mean the slope is equal to 0. If the slope is equal to 0, then you should say m equals 0 or slope equals 0. Okay, 0 is something. It's a way to quantify nothing. Number 3, if you write no slope as an answer, no credit will be awarded. Remember, if the slope does not exist, that's what you should write. If the slope is equal to 0, that is what you should write. Don't say no slope and use it interchangeably between slope is 0 and slope does not exist. So never write no slope. Some notes about this. Number 1, the slope of a vertical line does not exist or is undefined. All other lines, including horizontal lines, have a slope. Number 2, slope is just a number. Okay, it's not a variable, it's a number. Number 3, typically slope is a fraction. You think about the way it's defined, change in y over change in x. That's a fraction. Number 4, when slope is a fraction, it should be reduced just like all fractions should be reduced. You should always reduce your fractions, no matter where they appear. Number 5, we do not normally use mixed numbers or decimals for slope. In certain applications we do, but when there is no special application, we leave the slope as a fraction, even if it is an improper fraction. Now, there's nothing wrong with writing the slope as 13 over 8. Now, since most of our problems really are applications, meaning word problems, we will oftentimes write our slopes as decimals. So if there's going to be a decimal requirement, be sure you read the directions about any sort of rounding that's supposed to take place. Number 6, slope is a measure of how steep a line is. In absolute value, the greater the slope, the steeper the line. Number 7, a positive slope means the line is going uphill as we read from left to right. Remember, that was also the definition of increasing, that you're going uphill as you read from left to right. So positive slope means the line is an increasing function. Number 8, a negative slope means the line is going downhill as we read from left to right. And as you recall, that was the definition of decreasing. So a negative slope means we have a decreasing function. Number 9, a slope of 0 means that the line is neither going uphill or downhill as we read from left to right. The line is horizontal. All horizontal lines have m equals 0. That's a constant valued function. Because if m is equal to 0, then that means nothing is going to multiply the x in your slope-intercept form. You may recall that from high school as well. So remember, if the slope is 0, it's a constant valued function, a horizontal line. Number 10. A slope that does not exist means a vertical line. Let's have some pictures of this. So this one, our red line, it's going uphill as you read from left to right. That means the slope is greater than 0. The slope is positive. That's what m greater than 0 means, positive. Here, as I go from left to right, the line is going downhill, so the slope is negative. So m is less than 0. Remember, less than 0 means negative. In this picture, horizontal line, slope is 0. And in this final picture, I have a vertical line. And remember, the slope of a vertical line does not exist or is undefined. Some examples. Let's find the slope of the line that passes through each pair of points. Simplify your answers. Do not use mixed numbers or decimals in your answers. So you're going to simply write the fraction and reduce it. Here's our first one. I have the points negative 4, 6 and negative 9, 3. Okay, I'm going to let x1, y1 with coordinates negative 4, 6. I'm going to let x2, y2 be the ones with coordinates negative 9, 3. This way I can just refer to my points. I mean, they don't know who's first or second. So remember, slope is y2 minus y1 over x2 minus x1. So we fill in the numbers. Our numerator, remember, is the difference in the y's. So we're going to have 3 minus 6. My denominator, negative 9 minus negative 4. And then we just do the number crunching. Okay, so in the numerator, 3 minus 6 is negative 3. And my denominator, negative 5 minus negative 4, that's really negative 9 plus 4, so I have negative 5. So I end up with negative 3 over negative 5. A negative over a negative is positive, so the slope is 3/5. Remember what this means. The numerator is your vertical up, down. Your denominator is your horizontal left to right. We're going to always go to the right. That's how we read. We go from left to right. So this means that every time you move 5 units to the right, the denominator, you're going to go up 3 units to stay on the line. So right 5, up 3, right 5, up 3. If the slope were negative, we would still go right 5, but instead of going up, we would go down. Again, we're always going to go to the right, so that way a negative slope would mean go down, a positive slope would mean go up. Example number 2. I have the points 6, negative 7 and 6, 4. Okay, our solution, again, I'm going to let x1, y1 be the first point, 6, negative 7, and x2, y2 will be the second point, 6, 4. Just be consistent when you name them. Okay. Our slope, remember, is y2 minus y1 over x2 minus x1. And now we fill in the numbers. Okay, the numerator, 4 minus negative 7. Denominator, 6 minus 6. Okay, doing the math, 4 minus negative 7, that's 11. My denominator is 0. So I have 11 over 0. Okay, remember, we cannot divide by 0. So the slope here is undefined or does not exist. In fact, if you were to plot these 2 points, you would see that they are a vertical line. Remember from high school geometry, 2 points are what you need to determine a line. So again, if you plot those 2 points, you'll see that they do, in fact, lie on a vertical line. And now you see algebraically why the slope of a vertical line does not exist. It's equivalent to division by 0. We are never allowed to divide by 0. Number 3, I've got the points negative 3, 4 and negative 11, 4. So I'm going to let P1 be negative 3, 4, and P2 will be negative 11, 4. Remember slope, y2 minus y1 over x2 minus x1. Fill in the numbers, 4 minus 4 over negative 11 minus negative 3. I have 0 over negative 9, excuse me, negative 8. 0 over a non-negative number is 0. It's kind of like I have $0 divided amongst 8 people. Each person gets $0. So remember, 0 over a non-negative number, excuse me, over a non-zero number, I'll get it right here in a minute. So 0 over a non-zero number is 0. So the slope is 0. And if you were to plot those 2 points, you would see that they are in fact on a horizontal line. So the line is horizontal here in example 3. Now, when calculating the slope of a line, it does not matter which 2 points on the line that we use. Okay, this allows us to use ratios and proportions when solving certain types of equations that involve lines. Okay, in the language of math, we kind of say that the slope of a line is an invariant. It doesn't change just because you're using 2 different points. The slope of a line never does change. Once you've found it, that's it. It never changes. Now, before doing more examples, we're going to introduce some more notation. Definition. If x changes from x1 to x2, then the change in x is denoted by this symbol, which is read delta x. That triangle is the Greek uppercase letter delta. It's given by delta x is equal to x2 minus x1. Similarly for the change in y, delta y. So delta y would be y2 minus y1. So the Greek uppercase delta, when it's sitting in front of a variable, usually denotes change in that variable. And we could have a delta w, w2 minus w1, delta z would be z2 minus z1, and so on. Okay, remember, slope was change in y over change in x. So in terms of this new notation, m would equal delta y over delta x. Okay, provided delta x isn't 0. Remember, we cannot divide by 0. That would be a vertical line. The slope does not exist. Some notes about this. Okay, first of all, the rise is delta y. Remember, the rise is change in y. The run, remember, that was a change in x, so the run is going to be delta x. Rise can also be given in terms of the slope and these deltas. Rise is m times delta x. Another way of looking at it is delta y is equal to m times delta x. If I go back to a previous slide here, you'll see why. Remember, m is delta y over delta x. Think of this as m over 1. So if you do your cross multiplication, m times delta x is 1 times delta y, but 1 times delta y is delta y. So now you can see why delta y is m times delta x. That may become useful for some of our problems. So, slope is a rate of change. Okay? Slope is a rate of change. For a linear function, the rate of change is in fact the slope. Remember, we did that when we were looking for values not in a table for a function given by tables. Some examples. Number 1 says, construction laws regarding access ramps state that every vertical rise of 1 foot requires a horizontal run of at least 12 feet. Part A. Find the slope of an access ramp. Express your answer as a fraction in lowest form. Question B. Susie has been informed by her contractor that an access ramp for her front door must start at least 8 feet horizontally from the door. How high above the ground is Susie's front door above the ground? Express your answer in inches. Notice these are feet. Okay, our solutions. For part A. Okay, we're actually given that delta y is 1 and delta x is 12. Now notice, the units do match. Feet, feet. So our slope, remember, is delta y over delta x, which is 1/12. If you were to actually put the units 1 foot over 12 feet, the feet cancel and you just get a number, 1/12. Remember, slope is just a number. Okay, part B. Okay, we can use the following proportion. 1/12 is equal to delta y over delta x. Remember, change in y over change in x, with delta x equals 8 and delta y is unknown. So I have 1/12 is equal to delta y over 8. Remember, all of this is in feet, though. All of this is in feet. Okay, if we find our cross products, again, students always say cross multiply, which there really is no such thing. You're finding cross products. So 12 times delta y is equal to 8, right? Cross multiply. Divide both sides by 12. So you get 8 over 12 is delta y, but see 8/12, I can reduce that to, what, 2/3? So now remember, this side is in feet. So to convert to inches, recall that there are 12 inches in a foot. Simplify the above result, this 8 over 12, which is the reason I'm not reducing because of this 12, to convert to inches. So 8/12 times 12. Remember, the 12 is really 12 over 1, so I cancel. Okay. And I get 8 inches. So Susie's front door is 8 inches above the ground. Number 2. An office window is 55 feet high. That's what this is right there. Susie looks out the window and sees that a statue of a discus thrower, right here, lines up exactly with the bottom of a building that is exactly 650 horizontal feet away from her office. Okay, so this is her office building. This distance right here is 650 feet. If the statue is 125 feet from the other building, so this distance right here is 125 feet, how tall is the statue? Answer to the nearest hundredth of a foot. So here's our picture. So remember, the window, 55 feet high, 650 feet between the two buildings, and the statue is 125 feet from the other building. Now notice, if you wanted to, you could figure out how far it is from Susie's office building, but we really don't need to know that. Our solution. Okay, if you kind of look at the picture, I have a rise over run and a rise over run. So I'm going to let x equal the height of the statue. So this is x. So we set up the following proportion. Okay, it's really just slope. Okay, it's really just slope. Now, fortunately here everything is in feet, and I'm wanting to answer to the nearest hundredth of a foot. So 55 over 650, right? Rise over run is equal to x over 125, rise over run. Okay, and then once again we compute our cross products, right? 650x is going to be 55 times 125. And now I took out the calculator to do 125 times 55. So if I divide by 650, I got 125 times 55 over 650. That's x. So that's about 10.58 feet if we round to the nearest hundredth like the directions said. And again, just to take out the calculator here, parentheses, because they've got an operation, 125 times 55, close parentheses, divided by 650. And 10.576, so to the nearest hundredth, 10.58 feet. Number 3. A surveyor whose eye is 6 feet above the ground, so here's our surveyor with his eye 6 feet above the ground, sights a mountain peak that is 2 horizontal miles away. So from the surveyor to kind of like if I could bore down through the mountain, that is 2 miles. Directly in his line of sight is the top of a surveying pole. That's right here, that's his surveying pole. That is 8 horizontal feet from him, so from here to here is 8. And that is 10 feet tall. How tall is the mountain peak? So now see the picture below. Again, it looks like I have my rise over run bit. Now notice, these are both feet. I'd have 10 feet over 8 feet, and some miles over some miles. So our solution. Well, that's equal to the height of the mountain peak. So we got to convert everything to feet, because it doesn't say, but evidently I want to find the height of the mountain in feet, which that's more normal. So 1 mile is 5,080 feet, so 2 miles would be 2 times 5,080, which would be 10,560 feet. So now I've got everything in feet. So again, let's do our slope proportion. 10 over 8 is going to be x over 10,560. All right. Again, going back to the picture. 10 over 8 x over 10,560. Do your cross products. So 8x is 10 times 10,560. Divide by 8. And then if you crunch this out, 13,200 feet. Turns out it was exact. So again, if we do it on the calculator, open parenthesis because I've got an operation in the numerator, 10 times 10,560, close parenthesis, divided by the 8 feet, 13,200. That's the end of section 3.1.